I'm recording this.
Okay, sir.
We are going to do it in a different way. Let us read the number which we are going to check from command line argument, which need to be parsed into int. The command line argument value is args0. This is say 11. Okay.
Yes, sir.
This is n1. Let us have one more value. N2. This is args1 and let it be 10. Now call system.out.println. This is non-recursive result. Is prime. This time I pass n as well as starting value 2. Is the difference clear?
Yes, sir.
Earlier I was passing only n. Now I am passing starting value 2 with which you are going to divide. Now this is prime r and starting value is 2. Now non-recursive method. Followed by recursive method. First, non-recursive method. Both have same template. Public, static, Boolean, is prime, 2 inputs, n, and starting value of I with which you are going to divide to check whether it is divisible or not. Same template for recursive as well. In the earlier example, we took 2 different templates. Now I took same template for both. Clear?
Yes, sir.
Now here, what the condition? If n is less than 2 or n equal to 1, you return false.
Right.
In recursive version also, same thing. Okay. Now here what we do, while I is less than or equal to half of n, we check if n is divisible by I, then we return false. If you cannot, then you take next value of I and repeat the process. Take next I and repeat process. After that, if you could not return false, finally, after all possible values of n, you return true. Okay. Now see how I am going to convert iterative process into recursive process. What the condition? If n is divisible by I, return what? False. Otherwise solve remaining problem. What is remaining problem? What is remaining problem? With the next type. Is this clear?
Yes, sir.
There I put I equal to I plus 1. Here I call the method with the next type.
Yes, sir.
Okay.
Yes, sir.
There should be some stopping for I. Otherwise, I will continue to increase to infinity.
Yes, sir.
Now, what is the stopping criterion? While I is less than or equal to n by 2, you solve next problem. When do you stop? When do you stop? Reverse of this condition. What is that? When I greater than n by 2, you are outside the loop and you return.
True.
This is clear.
Yes, sir.
This is how you convert a while loop into if statement. You go into loop when I is less than or equal to n by 2. You come out of loop when I is greater than n by 2. So when I is greater than n by 2, you come out. Otherwise, you do what you are doing in the loop. I hope you understand it.
Yes, sir.
Now, n1 is 11, n2 is 10. Recursive input is 11, so corresponding output should be true. For 10, output should be false. Okay.
Yes, sir.
Second one is recursive. Showing some errors. 2 semicolons are missing here. So, got the outputs?
Yes, sir.
Now, I will extend it for palindrome. Palindrome logic with recursive and non-recursive. Let us take 2 strings, one for non-recursive, one for recursive. When there are already strings, then you need not parse. So string 1 is args0, string 2 is args1. Okay.
Yes, sir.
What are string values? The first one is Malayalam. Second one is madam. Okay.
Yes, sir.
Now, this is palindrome, and this is palindrome R. Right?
Yes,
Inputs
sir.
are S1. Here input is S2.
Yes, sir.
Okay.
Yes, sir.
Here I give 2 more indices because I check from left and right. Left index is 0. Right index is n minus 1.
Yes,
String length minus 1. Okay.
yes, sir.
String length minus 1 is right index. Here, string 2 left index is 0. Right index is s2 dot length. For string you need method, right?
Yes. Yes, sir.
Now, for the first method is palindrome. Is palindrome. What are inputs? What are inputs? String, left index, and
Right.
right index. Okay.
Yes, sir.
Now, the method while left index is equal to right is not equal to or less than right index. What does it mean? When there are at least two characters. Is this clear?
Yes, sir.
Left is less than right. When there are at least two characters, then compare them. Is this clear?
Yes, sir.
When there are at least two characters, you compare them. Now, how do you compare? If leftmost character of string is not equal to rightmost character of the string, then return false. Clear?
Yes, sir.
Otherwise, take next left character, next right character. How to visualize it? How to visualize it? Suppose MA, DA, M are there. Initially, left is here and right is here. Okay.
Yes, sir.
After that, the next iteration, left is left plus 1 and right is right
Right.
minus 1. Okay.
Yes, sir.
This is L equal to L plus 1, R equal to R minus 1. When we stop, it stop when there is only one character. We stop one when left is right. Is this clear?
Yes, sir.
We stop when left equal to right. We will do when left is less than right. I hope you understand these three illustrations.
Yes, sir.
Okay.
Yes, sir.
Just remove them. Otherwise, I will have to put comments here. Okay. Now, after checking all the characters, when left equal to right, you come out and return true. Now, what about recursive? See how simple it becomes. Is palindrome are inputs are string yes, left index and right index. Clear?
Yes, sir.
Now you tell me what is the condition? Say the same as this. They are not same, return false. Otherwise, solve the remaining problem. What is the remaining problem?
Return is valid.
What is the remaining problem? String yes, next left character, next right
Valid.
character. Is this clear?
Yes, sir.
So how long you do it? What is the limiting criterion?
L is equal
You
to.
can take it from outside. You can take it from the top. If L
Yes,
is
sir.
less than R, you continue. You stop when L equal to R.
Yes, sir.
Okay. You stop and return true.
True.
This is limiting criterion or base case. You can also read this as when there is only one character, then it is palindrome.
Yes, sir.
Did you understand it?
Yes, sir.
Is it simple to convert a non-recursive one into recursive one?
Yes, sir.
So in recursion, what we do? We take the next value.
Yes, sir.
Here there are two variables. In the earlier case, there was only one variable. Now, what are the outputs? Both should return true. What happened? There is space between not and equal to. I do unimaginable mistakes. There is no semicolon here. First one is false. Why? Malayalam should be true, right?
Yes, sir.
So why it is false? I increased L, but I did not decrease
R.
R. Okay.
Yes, sir.
One point will change, second pointer did not change. Now, let us make it. So first one will be false, second one is true. If I make D as capital D, will the result change?
No, sir.
Why? Because that character is a middle character where L equal to R. Clear?
Yes, sir.
But why it is false? It should be true, right?
Yes, sir. Please.
Because of this M. Let us make this also capital M. Now, is the first one true?
Yes, sir. True.
The last one of this session, this is highest common factor. Highest common factor or GCD, greatest common divisor, using recursion and non-recursion. The two numbers will be given. You need to convert them into, you need to find out highest common factor. Say int A int B if you take them as command line arguments, you must be converting them into parsing them into integer. Okay,
Yes, sir.
so this is B. Second one. Say these are for AB are for non-recursive method. Let us take two more for recursive method. I call this as capital A. I call this as capital B. This is args2 and this is args3. And I'm doing it to make you familiar with command line arguments. First two, 25 and 15. Second two, 42 and 26.
Yes.
What is the GCD for the first two?
5.
5. For second two?
2.
For second two?
2, sir.
It is 2. If I make it 52, it would be 13. Okay.
Yes, sir.
Now, this is GCD and this is GCDR. Now, inputs are A comma B. In the second case, inputs are capital A comma capital B. Is this clear?
Yes, sir.
Now, this is recursive and this is non-recursive. Both return integer, which is highest common factor or greatest common divisor. Function name is GCD. Takes two integers, say x comma y. A is taken as x, B is taken as y. This is GCDR. Let us take same pair of values. Capital A is taken as x, capital B is taken as y. Now, I think you know the logic. While x is greater than 0 or x not equal to 0 or greater than 0, what you do? You find out remainder. What is remainder? X modulus y. Now, new x is equal to old y. New y is equal to remainder. Is this clear?
Yes, sir.
And then you return what? You return x. Now I just follow your advice. Tell me what to do. What is the limiting condition? What is limiting condition? Sorry, this is y greater than 0. What is limiting condition? If y equal to 0, then return x. Clear?
Yes, sir.
I just rearrange the earlier one. Y greater than 0, do it. Y equal to 0, return it. Or you can say y not equal to 0. Okay?
Yes, sir.
Now, otherwise what should be done? Otherwise, solve the problem with new values. Solve the problem with new values. What are new values? What is new x?
Y.
Y. What is new y?
Reminder.
What is remainder?
X mod Y.
This is recursive method for GCD. That's all. New x, new y. So call the function with new values. And what is limiting criteria? Stop when y equal to 0. Clear?
Yes, sir.
So now is conversion from non-recursive to recursive easy?
Yes, sir.
What is the ground rule? Solve the problem with new values. Solve the problem with next pair of values. And decide a limiting condition. So for 2515, answer is 5. Parentheses are missing. A reminder should be declared. Any other errors? So for 2652, what is GCD?
26.
26. For 4226,
26.
2.
2.
Right?
Yes, sir.
If you have prime numbers, then prime numbers have no factors. GCD is 1. Is this clear?
Yes, sir.
That's it. So we discussed 3 different problems and we converted recursive version, non-recursive version into recursion. What is the rule used? Find limiting criterion and continue calling same function with next legal set of or sets of inputs. Is this clear?
Yes, sir.
Continue calling the same function with next legal set of inputs. Only these 2 rules for recursion. Hope you understand it.
Yes, sir.
Okay. Okay then. Thank you. Thanks for attending.
Thank you, sir.
I end the session here.